There are physicist Frank Rinn. He comes from Rinn Tech Metalware company from Germany. About his biography, Frank Rinn is a distinguished physicist and expert in dendrochronology and tree health assessment. He developed the needle-resistant drilling method for tree ring density analysis and founded Rinn in 1988, a leading company specializing in tree and timber inspection technology. Rinn holds numerous international patents, including for resistograph and arbotone, and has received multiple research and innovation awards. He lectured globally, contributing to standards in tree safety and conservation, and served as a core expert on timber structure restoration. His contribution to dendrochronology, climatology, and biomechanical safety have been recognized internationally, and he has actively shaping guidelines to evaluating the stability of tree and wooden structure. Rinn's work has been integral to the preservation of historically significant buildings and urban tree health management. The topic that in the Rings will speak in this Ecuadendro 2025 conference is related about Dendrogeomorphological terrain analysis method for damage reconstruction of urban trees. So you are welcome to start your talk. They are from Rinn. You
Thank you
can
very
share
much.
your presentation.
I switched on my microphone. I hope you can hear me.
Yes, it's possible to hear you.
Fine, that's great. Yeah, thanks for the invitation. Thanks for the introduction. Yes, I studied physics, and in 1986, I was asked if I could help technically an institute in Hohenheim, which is close to Stuttgart, southern Germany, where Bernd Becker was building up one of the probably still biggest dendrochronology workshops. And he set up a big chronology in oak and in several other species in southern Germany and middle Europe, basically. And so this was my second contact to wood, because originally I grew up in a family with a farm and a sawmill. So I was used working with wood from early day on. And after school directly, I started working as a carpenter, but then I realized, oh, not my way. So I switched to studying physics, and I loved it, and I still would do it again. Physics is really a great thing to do. And as I said, in 1986, I started working as a technician at the dendrochronology lab of the Hohenheim University with Bernd Becker. And since then, I just can't get rid of it. So since 1988, we are working in our own small company. Basically, we are developing technology for analyzing trees and timber, both in terms of structural stability, so wood condition, is the tree intact, is the timber intact, does something needs to be prepared, or does the tree need to be pruned because of safety reasons, and so on. And over the years, it became clear that in many challenges, tree ring analysis helps a lot. And I would today just like to show you some case studies, some of the many case studies I did since 1988, often as an expert in court where people fight about trees in the city. Sometimes the question, why did the tree collapse? For example, a few years ago, I had a court case on a tree that collapsed and killed 12 people standing in front of a church. And by tree ring analysis, I found out that obviously someone cut off major roots of that tree about, I think, 12 years earlier or 14 years earlier. So tree ring analysis often helps to find out solutions that are difficult to find. Okay, so as I said, I will show several case studies where we practically apply tree ring analysis in the urban environment. the need for urban trees is obvious. You know, urban trees significantly contribute to local climate. They are biodiversity hotspots, and we need more of them. And especially old trees are important in this context, because old trees, the older they are, the more important they are in their biodiversity contribution. So it's
sorry, Rinn, a
yeah.
question. Maybe are you share with us a screen, a slide?
Yes, sure.
Yeah, because I can't see. Maybe you forget to show us to share. Okay, now it's possible to see.
Okay.
Yeah, if you want to return a little, you can
Oh, it's
do.
okay. No, I was just
Okay.
talking about the first page. No worries. So as I said, I will show case studies where we basically apply tree ring analysis methods to typical challenges dealing with urban trees. So just a simple example, in many cases, it's about how old is a tree, just because when you plant a tree close to the property border to the neighbor, over the years, the tree may grow significantly in height and may probably shadow the solar panel of the neighbor. This is why in many countries around the world, there are legal boundary conditions that make clear which kind of tree is allowed to be planted in which distance to the property border to the next neighbor. So quite often we have to check how old is a tree. For sure, if you want to know it exactly, you need to cut down the tree, then the tree is gone. Often it's a part of a hedge, so we can take one or two out of it and we count. So in this case, again, the question of the court was, how old is this tree in reality? Because when the tree is there for 5 years in many countries, the tree can stay there because the neighbor should have complained earlier. So in many cases, the simple task is just counting the tree rings. And this is mostly relatively simple in conifer trees, but in the urban environment, and this is very similar to trees standing on mountain slopes, tree rings can be missing, partially or completely. So counting tree rings, sometimes it's easy, but it can be a pain. Another aspect, in the urban environment, more and more institutions, companies, institutions try to plant not very small trees, but quite bigger trees. And when trees are prepared for being transplanted into a city in the nursery, typically they are root pruned and transplanted in the nursery so that they don't build only one big taproot, but several small fine roots, so that then when the trees are planted into a city environment, they can adapt to any kind of structure in the soil. So the number of transplantings and root prunings in the nursery is a quality measure for trees when they are offered by a nursery for being planted into the urban environment. So in this case, it was a Sequoia-dendron, obviously seen by the cross-section. The institution, it was a hospital, wanted to have a nice big tree in front of the main entrance. And they purchased a Sequoia-dendron tree. Total price was $15,000, including the planting. But unfortunately, the tree died. On the invoice, it was specified that the tree was transplanted 6 times in the nursery and root pruned, so that it was well prepared to be transplanted into a city. But when we got the stem disc, we found out the tree was only 1 time transplanted in the nursery, because when you do the root pruning in the nursery, you basically strongly damage the root system, which is not good for the trees. But as I said, for that special purpose to prepare the trees for being able to adapt to any kind of structure in the soil when they are later transplanted into a city, it makes sense to do it, although it's not good for the tree, but that's the only way right now the industry is working. And that's practically the same all over the world. And the root pruning can be clearly identified by a very narrow ring. Typically in the nurseries afterwards, the trees recover from that root pruning within 1 or 2 years. In this case, it was quite quickly, but we could clearly show that, in contrary to what was specified on the invoice, this tree was not 6 times transplanted and root pruned in the nursery, but only 1 time, which cleared the court case about the tree. In this case, it was about 1,000 500, I think 1,500 trees probably, standing on a flood dam. So a dam that was artificially created for protecting a city from floods. And the government decided to plant trees on it. But after, I think it was 4 or 5 years, it was clear the trees were all starving and not looking good. A lot of them died. And then we got stem disc of these dying trees. And we found by checking the tree ring structure and the damages that were obvious to the cross sections at the stem base, all these damages had been caused by the mowing on the dam. That means basically the company that mowed the dam and had the challenge to have the grass moved away. Basically, this company had to pay for the damage, and it unfortunately went bankrupt over this damage. But the tree rings clearly allowed us to say when something happened to the trees, and then in the documents of the administration, it was clear it was the mowing time. Probably that they should have better put some sheep and goat on that dam or mow the grass instead of doing it with a machine and damaging the trees. Mowing damage is a major topic in parklands, in cities. We know endless numbers of trees in nice parks in the cities that were strongly damaged at the stem base by mowing. So this is one of the reasons why we typically recommend either planting some shrubs around the stem base, or mulching. In this case, a city asked us why hundreds, or probably more than 1,000 trees, mostly tilia in that city, didn't look good. They were suffering, and the city had no clue why that happened. So they sent us, I think it was 3 stem discs. So we did tree ring analysis, and we found out that severe damages happened to the trees that were not related to climatic changes. So we found drastic reductions in ring width at most of the trees. No, at all of the 3 trees that we measured. And these strong reductions were not related to any climate impact. So again, a study of the documentation in the administration showed it was the result of strong pruning. Because of safety reasons, the city was scared about big trees, so they ordered arboricultural companies to prune the trees, and they obviously over-pruned the trees. And by too strong pruning, basically topping the trees, they basically damaged their vitality so strongly that the trees were really starving by that. So the pruning regime was just wrong. Oh, going back, next slide. This is a typical challenge in the urban environment. Often we have tree species like here, where the discoloration makes it really a pain to identify the tree rings. Even when you sand it with 5,000 grit under the microscope, sometimes it's really difficult by the discoloration of the stems, due to various reasons. First of all, some species show it, and secondly, it depends on where the trees are standing. So in this case, we did a fine tree ring analysis. In this case, it was interesting. These are ring width curves. The red one is the average curve. Sorry, the labels are in German. When I put the tree ring curves of 3 trees that we analyzed in this case, and we show them, and we have some dotted vertical lines on the x-axis, which is the time, the year, that shows some synchronicity. But when we switch to the annual incremental area, that means not the ring width, but the annual incremental area, for the same samples, you see that the synchronicity increases, and it was much easier to find out the reason why these trees were dying. So sometimes it makes sense to switch from or in this context with urban trees, often it makes sense to switch from ring width analysis to the incremental area analysis. Actually, that's what we're doing since more than 30 years. So we started in the 1980s already, switching from just measuring and plotting the ring width. We switched already to using the incremental area, basal area increment, which really is helpful in this context. Another fun application, quite a successful German businessman wanted to retire, and he said, "Oh, for my retirement, I would like to have a nice big tree in my garden." So it was in wintertime. about 10 years ago, he checked the internet for a nice big magnolia tree because he loved flowering magnolia trees. And on the internet, he found a nursery offering quite a big magnolia tree. You see the tree here on the picture. He drove there in winter, visited the tree and the nursery. They offered him, okay, we will take the tree out of our ground here, put it on the truck, deliver it, plant it, and care about the tree. And the paycheck was 25,000 euro, which is approximately 25,000 US dollar. But in May, when the tree should flower, there were no leaves coming out. So the owner said, oh, the client said, oh, that's not nice. I wanted a tree with flowers. And he called the nursery and they said, yeah, you know, some trees show a planting shock. And after that transplanting in spring, that is normal that a certain percentage of the trees in this year will not show any leaves. So we have to wait until next year. The next year, again, there were no leaves coming. And a gardening guy from the neighborhood came and said, this tree is dead. So the consequence was we got the stem disc and we should analyze the stem disc. That's the stem disc of that nice magnolia tree. You see, it's quite an age, yeah? It was not a young tree. Analyzing tree rings of magnolia, it's not that easy just because of the coloration. Identifying the tree ring borders are sometimes quite difficult. So we did ring width analysis for several radii of these two cross sections. And we calculated the basal incremental area time series. So we typically create index series, in addition, checking what is going up and down, so positive and negative pointer years. And by doing that, we found, oh, something looks strange because these trees, this tree was born approximately 1953. And we know that 1976 and 2003 had been the driest years in our area in Middle Europe in the last 50 years. But in these years, the tree didn't behave like it should be, the time series. And we found out, oh, we have to shift the time series back by at least 2 or 3 years. And finally, it came out the tree was already dead in the nursery for 2 or 3 years. So they basically sold him a dead tree, which is not nice. And you can imagine the court case was not very good for the nursery. So they obviously hoped that the customer would accept that there is a certain failure rate that the tree that was purchased and transplanted will fail and will not be able to establish himself on the new plantation site. So obviously this was not a good thing, but yeah, the court case was clear because we could clearly show this tree was already dead for at least 2 years in the nursery. Another aspect, trees in a urban park that originally was nearly like a forest, but then it was used step by step by the city as an urban park. And the city asked us why the trees were starving, were not looking good, and some trees even died. So we got the stem discs of 3 oak and 1 tilia. In the oak trees, it was obvious, and that was interesting to me as well at that time. The tree ring structure, you can clearly see here hardwood and sapwood, and you see there is a nice clear transition from this point on. From this point on, the tree rings basically only showed early wood. What happened to these trees? In this year, a group of people with permission of the city started a folk festival in that park, and hundreds of thousands of people came in that park that was hardly used before that time. So for the first time, this park was heavily used by people, and the compaction to the ground limited the uptake of these roots. So compaction, not only by big machinery, but even by many people, can be a challenge for trees. So the ring width really dropped down dramatically. And as you see, the oak trees only set up early wood anymore, no late wood anymore. And then the tree died approximately, I think it was 18 or 20 years after that switch. So obviously the tree was able to survive this challenge for about approximately 18 to 20 years, but then it was over. So again, we did tree ring analysis, ring width curves with trend analysis, because usually we have to present the results to politicians or to courts. That means insurance companies, judges, lawyers. So some people, usually these people don't understand a lot about biomechanics. They don't understand typically anything about time series analysis or dendrochronology. So it's always a question how to present the results. So as I said, we typically show the ring width curve, the trend curves, then some index curves where we just look for changes from year to year. For these trees, this is the oak, that's the tilia here. And then what is interesting, when you show these results, like in colored graphs, and as I said, the less people understand from these topics, the more they believe in colored pictures. This is the ring width curve. The average value is the 0 line for every tree. And down here, the tilia, these are the 3 oak trees. And this gives a very negative impression of the vitality of these trees. But when we show the basal increment area of these 3 trees, we see that actually the first one and the third one here, they developed quite well. Only the second one developed quite bad. That was the one with the extremely squeezed tree rings, only consisting of early wood. So it shows again that this tree really was suffering from that boundary situations, but the other two is not. So there was actually no need to cut down these trees. I think they would have had the potential to recover from that problem with these a lot of people and compacting the ground. So again, it's not only about what we found, but it's often about how we present it to our customers, in this case, not scientists. Yeah, again, left, you see the ring width curves shown in that kind of graph, and right, you see the basal incremental area curve, which I think for these purposes is much better suited. Okay, the next example where we came to a limit of tree ring analysis. A whole forest died within a few months, and the government asked us if we could find out by analyzing the tree rings if it would be possible. But we analyzed the tree rings, and it was about several hundred beech trees, really beautiful trees. The tree rings had been difficult to analyze because of the discoloration. That was quite a bit complicated to measure the tree rings. And you can imagine that the ring width series look completely different from depending on which direction you measure. So we measured the tree rings. We had not been able to identify a specific reason why the trees suddenly died. But we had been in good contact with Frieder Hoffmann. He unfortunately died a few years ago. But he did a chemical analysis of the cell walls, and he found that the trees had been poisoned with a special chemical that typically comes from biogas facilities. And this was the hint to the solution for that challenge. So a biogas facility on a big farm a few kilometers away, so a few miles away from that forest, they had a crack in the basement, and that chemical went through the crack into the groundwater and basically killed the whole forest. Another funny application here. We had the challenge for a court case to check since how long are these tuya trees taller than 2 meters? Is it 5 years or longer? So we thought, oh, let's cut them or a few of these stems lengthwise and measure the height of the pith. But actually that was very difficult because, as you know, the pith is never really straight. So it always goes around, and you can't follow with a saw that flibbering pith when it goes up. So we had finally to cut the 1/2 into several stem discs, and here we see the pith is always in another location. But finally, we had been able to say how long, at which time the tree reached which height, which was then extrapolated to the whole hedge of that for that court case. Here it was the challenge, interesting challenge. More than 1,000 trees were planted along a street, along a new road, but a lot of them died within a few years after the planting. So we were asked if we could find out why. We did tree ring analysis. Again, the discoloration made it difficult to identify the tree rings, but it worked out. We did the typical time series analysis, and the result was the trees were planted too deep. The preparation in the nursery was well, so the ring width curves and basal incremental area curve were all good and clearly showed the trees were well prepared, but they were planted too deep. And planting too deep basically kills the roots because of not enough oxygen in the ground and too much compaction. a very common problem, unfortunately. The biggest challenge we ever had was dealing with the problem where a city went to a court and wanted to have 100 million damage compensation by a gas company because they claimed that from 20,000 street trees that died within a period of 3 years, about 20,000 street trees died because of gas in the ground. And so we did tree ring analysis, measured the ring width of these dead trees, and did index studies and detrending showing these curves. And for example, here in this curve, the ring width curve you see here, the trend, this is an index down here. This kind of an index is a so-called neighborhood index that we calculated. And this shows in this time series, something really happened in 1992. And based on these analyses for these 20,000 trees, we were able to find out approximately 30% of these trees were killed by gas. Approximately 30% were killed basically by double-sided root trenching for fiberglass, glass fiber lines. And approximately 30% died in consequence of groundwater extraction for setting up new governmental buildings. So the 100 million euro that had to be compensated had been divided into basically about 3 parts to compensate the city. So coming to an end, analyzing urban trees is possible and it helps in many cases, but we have to be careful. Sometimes the measurement is really a pain. So sometimes for a stem disk, we need 1 day to identify the tree rings. And in addition, as I mentioned already before, the tree rings can really fade away, be very narrow. You can still measure them, but often they just disappear partially or completely. And I'll show it here on one slide. You can see 2002, the year 2003, you can only see here on the right and on the left. 2004, 5, 6, 7, 8 is only here, 9 here, and 10 here. So here between 10 and 7, there is no indication at all that there are other tree rings in between. So taking an increment core in many cases is not the solution. So we often need to have stem disks. When the trees are dead, that's not a problem to get the stem disk. But when we take increment cores to work on living trees, we always have to be careful and do a fine and a good cross state with other reference data to find out if we really covered all the rings. Yeah, so summary and conclusion. I think I made it clear it's far away from science, but we apply scientific methods. And with the increasing awareness of, I think more and more politicians in many countries are more and more aware how important urban trees are and how important it is to care about their health. And this is why we more often do tree ring analysis, unfortunately often on dead trees, but we can learn a lot from these trees. And I was always reminded working on these trees to the work that I did with Fritz Schweingruber in Switzerland. He showed me a lot how to deal with trees growing on mountain slopes. They have very similar damages, like an avalanche comes down, this damages the stem, roots are lost because of whatever happens on the slope. And interestingly, what happens in the tree rings is very similar what we found in urban trees. So this science is really important, and I think and I hope that in the future more and more people will be aware so that there is more application of that method in the urban environment. Thank you.
Thank you so much, Frank, for your interesting presentation. If any participant have some question, you are welcome. Please.
Probably my topic is so far away from your science that there is no question. I hope it's not boring, because actually
No.
these applications are really thrilling. You know, when you imagine you are in a courtroom and it deals about 100 million, that's really a lot of money.
Yes. Here we are very active because this conference sound very interesting. No boring.
Okay.
Yes, they are, Dr. Steinberg.
Very interesting talk, Frank. Thank you so much. we're definitely interested in this and the biomechanics of trees. We get totally involved with time series analysis and all that, but we love trees. People love trees, and more power to you. But
Thank you.
I don't have much of a question, but I'm wondering, what is your affiliation with St. Charles, Illinois?
That's my cousin. That's my company in America.
I see. Do
Yeah.
you go there sometimes? I'm in
Yes,
Arkansas.
several times a year.
Do you, honest? I'm wondering, have you ever been to East St. Louis to
Yeah.
Cahokia Mounds and seen the marvelous hardwoods that are growing there on the park around the Cahokia Mounds? What a
Yes.
marvelous set of urban trees. And that's an urban center that's over 1,000 years old, Frank. What did you
Yes.
think of that?
I was there 3 times already, and I shall be there in September again this year. And we do trainings in St. Louis frequently for arborists, how to care about these trees. And every time I'm there, I'm so fascinated. I love it. Really love it.
Listen, I'm inviting you to Fayetteville, which is not too far. It's 5-hour drive, or maybe I'll come to St. Louis,
Let's meet
in
there. Yeah,
September.
great. Would be great.
And
Yeah.
I'd so much like to meet you again. I think we met once or twice I know we did, during one past conference, but no, I
Long
love
ago.
what you're doing. This is in fact, you can make a career out of this as you prove, right? You don't have to be, an academic necessarily.
Exactly. Exactly. And I'm really, I'm in business now for 40, no, nearly 40 years in that area. I can really say there is a need for tree ring scientists in that world of caring about urban trees, and it is growing. In Germany, this market is growing about 10% annually since 25 years. In this case, we don't complain about the European regulation because the European Union in the 1990s established a system that basically forces governmental offices to care about old trees as long as possible, even when it costs additional money. And the additional money came from other funds. So it really boosted our economy, our tree care. And interestingly, when I started working in that field in the 1980s, a lot of Germans asked me, how could I move to America to work on trees? Since about 10 years, we have more people coming from America asking how can they get a job in that field in Germany, because our market is so strongly growing because of the regulations of the European Union. There's a lot of things to blame on that. There is a lot of bad regulations, but in this case, the regulation is good.
Well, congratulations. Very interesting.
Thank you.
Thank you so much, Professor Staley, for your question. Okay, for your contribution. And maybe another participant, would you like to make any question, any comment?
I would like to ask a question
Yes, you're welcome.
into the audience. What do you think is the city worldwide that invests most money into the preservation of urban trees?
This question is for me?
For you, for all
Oh, yeah,
attendees. And
for
I'm really
all
curious if
attendees.
someone has an idea, which city worldwide invests most money? And
I I think the Professor Staley know.
Oh, I don't know. No, I don't know. But
American, no?
do you? What do you think, Kelly? What do you think? What would you imagine would be the city most interested in their trees?
Oh, yes. So many times I could hear that um, Ecuador, because we are in the Ecuadorian line.
I can
Maybe.
solve it. I
I
can
would
solve it.
say I would say maybe Tokyo.
Oh, that's a good comment, but it's not because of the huge density of buildings in Tokyo. It's Hong Kong. Hong Kong invests the most in the preservation of urban trees. And I'm there quite often, and I'm really blown away every time how much they invest in that and how much they invest in the education of every employee working on trees in the city. It's really mind-blowing, and we can learn a lot from them. In Hong Kong, it's the result of an accident, like in many other cities as well in that field. About 20 years ago, an important person was killed by a falling tree, and politically important person. And so the city decided we need to take that challenge. And then they decided to allocate huge amounts of money to educate, to train the people how to care about trees, how to properly.
Thank you so much. So
largely ignored it. And then, just one example, in the year, I think 2000, about 10 people were killed by a tree. And then this government decided we need to care about urban trees. And this triggered the campaign in France.
Very good. Very good. So we are in the final step. Frank Rinn was the last speaker. If any person want to share any words for this event, you are welcome. We have a little minute for sharing any comment, anything, because we are finishing our conference. If any people want to share any words, you're welcome.
Well, let me just say thank you very much for Ecuadendro. The first session, that's just great. And I see great potential for scientific application of the native trees in Ecuador and throughout the Cordillera, of the Andes and of course in the Amazon. It's just like the southwestern United States in the early 20th century. This is just beginning. And I so much appreciate your organization, Kelly, and I wish you all the success with your dissertation and with your effort to get, legal interest and legal authority over the dendrochronologically significant trees in Ecuador and the old trees throughout the Cordillera. So thank you so much for including me and for your energetic efforts.
You're welcome there, Professor. You're welcome for your nice words. And any assistant, if you want to share any words, you're welcome. Have advantage. We are in virtual way. It's not easily when we are face to face. We can make a lot of things.
I can just repeat a big thank you, because I know it's a lot of work organizing these conferences, and doing it online is a special challenge. I know that. It's much easier being on the site and seeing each other. But I think you made a great job. Great. Thank you again. And you should do it every year. You should do it every year.
Yes, we will see the next year if we have that life. Yeah.
Yeah.
We will see you again. Yeah. So
thank you.
I will.
Kelly, can I have some more?
Yes, you are welcome.
Yeah. Thank you, everyone. It was an unique opportunity. Thank you, Kelly, for organizing such events. Because in our country, we really don't get some opportunities like this to have dendrochronology conferences and to come up with great scientists from all over the world, experts from all over the world. And when I was in my bachelor and master's days, I read some papers. So now I could hear from them like when I went after methodologies part of some papers, I heard about Rinn and use their when I crossed date and date, I used I heard about Rinn. So when Frank Rinn were giving his speech, his keynote presentation, it was personally, I was glad to hear from him. And one thing I want to add about Frank Rinn that I was thinking about how we could apply dendrochronology, and mostly we think about the forest restoration or forest kind of approach, but you showed us that we also can use it in like you did in cities, and applying it in different ways. So it was very informative and interesting. Thank you so much, Franklin.
Thank you so much for your noble words there, Rafael. Thank you very much. So, no more? Or the Dr. Neil Peterson? Okay. Maybe if you want to turn on your microphone, the Dr. Neil Peterson, you can turn on.
Yeah, I can.
You're welcome.
Sometimes I'm shy. This is a great conference. Kudos to you and the organizers for putting it together. I echo what Dave and Frank said. I've learned a lot. And I think it's a great idea to keep things going in our science, to bring people together around the world when they can't travel to other places, and to share our experiences and knowledge and understanding and help the science move forward as a whole. And so we don't have to always wait every 2 or 4 years to go to the hemispheric or the global conferences. This is a really wonderful opportunity to fill in some of those gaps, and I really appreciate it.
Thank you so much, Dr. Neil. So, I have some words here I want to share with you. Okay, about our closing remarks from Ecuadendro 2025. Distinguished Rinn Society member, scientific review committee, esteemed speakers, and their assistant. As we conclude Ecuadendro 2025, the first Ecuadorian Dendrochronology Conference, we are not merely ending a scientific event, we are celebrating a historic milestone. This has been a pioneering event, the first of its kind in Ecuador, marking a new area in the field of dendrochronology in our country. I want to emphasize the crucial role each of you has played in this achievement. The Rinn Society member or scientific review committee has ensured the excellence and rigor of every contribution presented, and their dedication has been instrumental in the success of this groundbreaking conference. To our speakers, your valuable insight have illuminated new path in this fascinating science. Your presentation have not enriched our understanding, but have also inspired future research and collaboration. To our attendees, I deeply appreciated your active participation and enthusiasm. Your presence has established this event as an essential forum for the international scientific community. laying a solid foundation for future conference in Ecuador. This first event in Ecuador will not have been possible without your commitment and dedication. You are all part of this celebration and this significant step forward in the history of dendrochronology. With heartfelt gratitude, I wish you continued success and discoveries. Until the next edition of Ecuadendro. Thank you very much. See you in our next edition. Chao a todos. It was a great pleasure to meet with you. Thank you.